Hi everybody, my name is Nagesh Cherukuri and I'm going to talk to you about hybrid tables. What we wanted to cover is how do you configure, how do you measure, and how do you optimize when you are trying to use hybrid tables in Snowflake. We'll give you some tips and tricks. We'll call out some, what are the pitfalls you should watch out for. But before that, let me introduce myself. My name is Nagesh Cherukuri and I'm from the field CTO team at Snowflake. I've been with Snowflake for 2 years, and I go broad on data applications. And I have here Dimitris, who's going to introduce himself.
So nice to meet you all. My name is Dimitris Turganis. I'm a principal software engineer at Snowflake. I'm one of the founding engineers of hybrid tables, and I'm one of the lucky guys to have a Unistore t-shirt. I can sell it for you if you want.
Thank you, Dimitris. What we'll do is today's agenda is we'll introduce you to hybrid tables. Some of you already know. Then we'll talk about configuring, monitoring, and optimizing. Those are the three topics which our engineer from hybrid tables Unistore team, Dimitris, will take us deep. And we'll take some key takeaways from this session. What are the things you need to really watch out for if you are going to use hybrid tables once you go back. With that, what is hybrid table? In Snowflake, as you know, there are different types of tables. And hybrid table is one of the type of table which we introduced apart from the standard tables we have. And Dimitris was talking about Unistore. Does anybody know what's the relation between Unistore and hybrid tables? Unistore is the encompassing, and hybrid table is just a feature in Unistore. So we interchangeably use Unistore and hybrid tables, but frankly, today we are going to talk about hybrid tables. Once Unistore comes in, Unistore is an umbrella of the features which we eventually encompass under that umbrella, and hybrid tables is one such feature. The intent of hybrid tables is to provide you with analytical and transactional capabilities in one engine. And why do we need to do that, right? What's the advantage of doing that? Today, due to lack of this, you basically have to do an ETL. Once you do aggregate, transform all the data, you eventually pump that into a transactional store like DynamoDB, Postgres to serve your applications, front-end applications. If you have both of them in one engine, you can avoid that complex ETL processing, avoid that effort. If you have to categorize, what are the big benefits of hybrid tables? One is this point operations. Today, since it's an OLAP engine, the standard tables gives you few hundreds of milliseconds to few seconds of response time. With hybrid tables, the idea is if you're looking for point lookups, you'll get these in double-digit milliseconds. That's the biggest advantage. The second one is the simplified architecture, as we talked about. You can eliminate that ETL. You can have both transactional and analytical in one engine. The other one is unified governance. If you're moving data from one store to other store, you are responsible for governance, management, security, so on and so forth. If you have all the data in one engine, you're basically avoiding all that. So let's look at the architecture, right? Pretty straightforward. Both the top two layers, the cloud services and query processing layers, there's not much change. The actual change is in the storage engine, where you see that there's hybrid tables alongside standard tables. That hybrid tables provides you with both that operational and analytical in that storage layer. So it basically combines both operational and analytical capabilities in one storage engine. But as far as the queries are concerned, the query optimization or the query processing, those two layers in the cake remain the same. The actual change is in the storage engine. So what use cases are we planning to address with hybrid tables? Primarily, we try to limit the use cases. We probably will eventually expand as we go further. As you guys know, we are currently in public preview. That means you guys can go ahead and try these. The three use cases which I wanted to touch on are application state. If you have an application state today, if you have to carry that, you basically need to have another OLTP engine like Postgres or DynamoDB alongside your Snowflake engine, which is OLAP, so that you can have application state managed in that OLTP store, which needs low latency access. So in such use cases, we wanted to address that. You don't need to manage another sidecar for managing the application state. You can manage that using hybrid tables because hybrid tables will give you that low latency access to retrieve the application state. The second use case, one of the customers I can probably reference here is Siemens, who's using this as an, to store the session state or an application state which needs low latency access. The second one is data serving use case. One of our customer, Mutual of Omaha, they are using it for data serving. So they can serve the use case, their front-end application for low latency reads and writes. They can use hybrid tables to do their backend. They don't need to rely on another OLTP engine alongside Snowflake. So they can do both analytical as well as operational queries, the data serving queries, using hybrid tables. They are all powered by a single data set in the backend. The third one is the lightweight transactional applications, where you need to do point lookups and you might have to do random writes. Since hybrid tables is at a row level locking when compared to a table level locking with standard tables. With standard tables, you get the table level locking, and that's why the writes will be cumbersome. But with hybrid tables, you basically get that low latency writes. Random writes can be provided in the single data set in the hybrid tables. So any lightweight transactional applications, William Hill is one of our customer who's using hybrid tables in such use cases. So these are top 3 use cases we prefer you try it out with hybrid tables. And how to configure and how to monitor and how to optimize this, I think Dimitris will cover this.
Thank you, Nagas. I think you skipped one slide. So let me talk about how we configure hybrid tables. So it's very easy to configure hybrid tables. It's very easy to create a hybrid table today using a slightly modified DDL syntax, as you can see on the example here, where you specify the hybrid keyword. And with that, you take advantage of features that you expect to find in other, let's say, traditional database engines such as Postgres or MySQL. For instance, you can create primary keys and foreign keys, or specify secondary indices in order to optimize your hybrid table queries. And these are some of the features that are available today with hybrid tables. In addition to that, you can use via SQL, you can combine hybrid table data with any other type of data that you have hosted today in Snowflake, as you can see in the following example, where I combine historical and transactional customer data in a very simple SQL statement. One thing I'd like to note here is that there are virtually no restrictions on what kind of SQL statements you can write today against hybrid tables. So as Nages mentioned earlier, hybrid tables under the covers combine a transactional and analytical storage engine. Now the good news for users is that you don't have to explicitly manage the operational and analytical side of your data. We do that for you. So how does that work in practice? When applications write data, data land by default on the operational storage engine, as denoted by the orange arrow. When data land in the operational storage engine, automatically we copy the data and we transform the data into the analytical storage engine in a format optimized for analytical workloads. So when applications now read data, we decide based on a number of factors, including your query access patterns, your query history, and a number of other factors, what is the best way to retrieve the data for your queries. In addition to that, we aggressively cast data at different levels in order to optimize especially recurrent query patterns. Finally, and one of the things that it's important thing that differentiates hybrid tables to other engines that claim to do both analytical and transactional data is that we always retrieve the latest committed data with virtually no lag, irrespective of whether the data are coming from the operational or the analytical storage engine. Now let's move into how we monitor and analyze hybrid table queries. One of the key questions that users are asking when they start running hybrid table queries and try to debug the performance of hybrid table queries is, which engine did my query use? Did it go to the analytical store or the operational store? In order to make it easy to answer questions like this, we have augmented the query profile, as you can see on the slide, with extra information that includes the scan mode that indicates which storage engine was used for a particular access pattern. As you can see on the left-hand side, a row-based scan mode will indicate that your table were accessed from the operational store, whereas a column-based scan mode indicates that the analytical store was used instead. One thing to keep in mind is that for a single SQL statement, we can access data from both engines at the same time, and the decision is made at the table level. So as you can see in the example on the right, where I joined the customers table with the orders table was accessed from the operational store using an index, whereas the customer table was accessed from the analytical store because it had potential to scan a lot of data. So how do we monitor and observe, essentially, our hybrid table workloads? In order to be able to make it easy for users to monitor their workload, understand the performance, understand the storage consumption of hybrid table workloads, we've introduced a number of account usage and information schema views. Now, word of caution if you're an existing Snowflake customer is that you should not be using the query history view in order to understand the performance and characteristics of hybrid table queries, because this view only has a limited set of information about hybrid table queries. In particular, it contains only those queries that run for more than 500 milliseconds. So you might be missing a lot of data. Instead, you should be querying the aggregate query history view, which is particularly tuned and tailored for hybrid table workloads. The aggregate query history view is a very powerful view, and there are many things you can do with that. For instance, you can see in the example here, with a very simple SQL statement, I can understand the average throughput of my application over time. Now, understanding storage consumption, again, is made easy using the following storage usage views, such as storage usage, account storage database history, as well as hybrid tables, which includes information about what are the tables that the hybrid tables that exist in my account. A key aspect in understanding and troubleshooting hybrid table workloads is understanding the behavior around transactions and logs. Consistent with other database engines, such as Postgres and MySQL, hybrid tables use row-level locking instead of table-level or partition-level locking. But even with row-level locking, transactions may block each other, or they may run into a deadlock. So let's see the following example. In one session, a user begins a transaction and updates the hire date of an employee, and then instead of committing the transaction, it goes for happy hour. Another session, a user tries to update the salary for the same employee, but because the first transaction held a lock on that row, the second statement has to block, waiting for that transaction to finish. So what are the tools that we have to understand the behavior of logs and transactions and mitigate situations like this? One of the things we have available is show logs. Show logs, you can use it in order to understand which transactions hold which resources and which transactions are blocked waiting for some resources to be released. As you can see in the example here, I do show logs on the table employee and understand what's happening with respect to the situation I described in the previous slide. In addition to that, you can use show transactions in order to collect information about transactions, such as which user is running it, which session, and other useful information. And if needed, an account administrator can easily abort a problematic transaction using the abort transaction system function. It's very easy and can mitigate situations like the one I described earlier. Now, the last part of this section is let's talk about how you optimize hybrid tables. And I know this is a topic that's of interest to many of you. So in general, you know that in Snowflake, we value simplicity and ease of use. And we try to make hybrid tables performant right out of the box. Still, there are a few things you can do in order to improve and tune the performance of hybrid table workloads. These things are warehouse selection and index selection. In terms of warehouse selection, we suggest using extra small warehouses for low latency point operations. And if you need to scale your workload to high concurrency, we suggest using multi-cluster warehouses. Finally, and something which I cannot stress enough, is that if you want to get the best performance out of your hybrid table workloads, you need to isolate your workloads to dedicated warehouses as much as possible. That will give you the best performance possible and minimize interference with other workloads. Now, in terms of indices today for hybrid tables can be created in two ways. The one is explicitly if you create with a DDL syntax, or implicitly when you specify constraints on hybrid table columns. For instance, if I specify a unique constraint or a foreign key constraint on a hybrid table column, under the covers, a secondary index is created in order to allow for this constraint to be enforced efficiently. Now, irrespective of how the indices are created, there are a few things that you need to be aware of. The first is that indices take up storage space. The second is that indices incur I/O cost, especially during DML operations, because the indices need to be kept up to date with the base table. And the last thing is that indices, irrespective of how they're created, they will be used in order to optimize hybrid table queries and optimize the access path. So the question here is, how do I choose the right index to create for my workload? We have a few recommendations, but in general, you need to experiment essentially and understand which indices work better for your workloads. The main recommendation here is that you should be creating indices on columns that are very selective predicates. Another thing that you need to be aware of, given that indices can be created in multiple ways, is that you should not be creating indices with overlapping columns, because if you do that, you're just paying the overhead, the cost for storing these indices, the overhead for updating those indices, and without getting a lot of benefits. In order to make it easy for users to experiment with different indices for your workloads, we made index creation an online operation that doesn't block any other operations and doesn't interfere with your running operations or running workloads. Few things on indices that I like to point out, which is something that we've seen customers hitting very often. Indices, we know that they can speed up hybrid table queries significantly. However, in order for an index to be utilized in a hybrid table query, you need to have a predicate on an index column, and that predicate has to have a specific format. As you can see in the example, the predicate needs to be of the form column, equality or inequality operator, and a constant, or an int predicate. If you specify predicates of that form against index columns, then an index couldn't be used in order to improve the performance of your queries. However, if you specify complicated predicates on columns, on index columns, such as string functions, or in general more complicated expressions, then the index will not be utilized and you'll end up scanning a lot of data. In order to make it easy for users to understand which index was used in a particular query, as well as which predicates were used, we augmented the query profile with added information such as the access predicates that indicate exactly which predicate was used for that particular index, as well as the full index name to show you exactly which index was used. And all that information is in the query profile. Lastly, an important tool for improving the performance of hybrid tables is covering indices. Covering indices, it's also a popular feature in Postgres and MySQL, allows you to specify additional columns to be stored as part of the index. That allows certain queries with specific access and predicate patterns to be executed significantly faster compared to using a traditional non-covering index. Let's see an example here. Imagine that you have a customer table where stored as a hybrid table, and then you have last name and first name, some of the information that you have that you track per customer. Now, if you have a select statement that essentially tries to get the last and the first name of all the customers that have the last name named Chirogiannis, using a secondary index, that query will require significantly more I/O because the first name, which is the column, needs to be retrieved from the base table. In contrast, if you specify a covering index that on the last name that includes the first name, that allows the same query to be executed significantly faster because all the information it needs is available on the index itself. In general, secondary covering indices have the same storage and performance trade-offs as standard secondary indices, and they have the same restrictions with respect to the predicates that you can apply, if you can use in order for the index to be used. The same thing I mentioned earlier for secondary indices. With that, I'm giving it back to I guess for the key takeaways.
Awesome. Thank you. Thank you, Dimitris. So with that, I would like to cover some key takeaways. So one thing is, if you are starting with hybrid tables, you should start with extra small warehouses. And as far as warehouses are concerned, right, start with extra small. If you have multi-concurrent requests, start with multiple warehouses, multiple access warehouses, and also go for isolated warehouses. Don't combine the workloads of standard workload with hybrid workload. Start with extra small. If you have multiple requests, use multi-cluster warehouse and go for isolated warehouse if you want to start a performance test. The second one is, as Dimitris said, don't look for query history because all the hybrid table queries are not going to be in your query profile. If you want to look for these queries, they will be in aggregate query history, where because you'll be doing a lot of tests, we'll be providing you the repeated parameterized queries over time in the aggregate query history view. And monitor hybrid tables. How do you monitor hybrid tables? As we said, we provide some functions like show transactions, show logs, describe transactions, whatever Dimitri showed you. If you want to monitor how you're doing, what the performance is, those are the key functions you need to watch. That I would like to conclude this session by giving you some tips. Understand your workloads, right? Hybrid tables provide you a balance between your query performance, between your analytical queries and transactional queries. So first of all, before you start, identify what are the workloads which needs hybrid tables. And the second one is getting the most out of hybrid tables require some experimentation, right? You are not going to get it right on the get-go. So that's why we suggest you to start with extra small warehouses, figure out and measure performance. We have seen people, customers, when they start trying out hybrid tables, they come to us with, hey, the performance is not there yet. The reason why they say that is, there are a couple of things you need to do to measure performance. You make sure your deployment and your test bed is in the same region and same cloud provider. If not, you're going to see varied performance numbers, varied SLAs. So the first thing we say is both the test bed and the hybrid tables deployment are in the same region, same cloud provider. The second thing which you need to watch out for is you do a test. You just run 1 or 2 queries and then don't get the SLAs. Instead, you warm up these clusters, run for 5 minutes, throw away the first 5 minutes, and then measure the next 15 minutes to really find the numbers of how it's doing in terms of performance. The third thing is that we have been in private preview for a while. Right now we are in public preview. We're going to be GA'd soon, but it's an evolution. We are finding things, we are learning, and a ton of feedback is coming from customers, which is being incorporated. That's what the public preview is for. With that, I think we conclude the session. Thank you.